All right, let's jump into question 10. In a recent survey of 750 Americans, 600 claimed to watch football. So here is a sample, and what we're trying to do is we're trying to make a claim about the entire population. And that's exactly what this section is talking about, estimating population parameters. In this case, the parameter that we're talking about is the percentage of people that watch football. So the percentage of people, hopefully you can be saying to yourself, okay, well, I know that that is not an average. I know that's not a mean. So in this case, I'm looking for a proportion, and that's a good thing. So I'm looking for the true proportion of the population. To do that, I have to calculate the sample proportion that I've been given, and I'm going to do some math on that sample proportion. In this case, my sample proportion is 600 out of 750 because there's 600 that do watch videos or American football out of my 750 total. The next thing I need to be able to estimate my confidence interval for my parameter here is I've got to come up with a margin of error. But let me come back because I'm actually solving a question that I don't need to solve. This question is purely asking for the point estimate. That's all it's asking for. And the best point estimate for the population of Americans that watch football is just a proportion based on the data that I've been given in my sample. So I'm actually done with this first problem. It's asking for a proportion of the population that watch football, and I've been given it right there, 600 out of 750. If you wanted to type that into the calculator, you can. You can get the estimated value as a decimal place, which would just be 0.8 or 80%. Either one of those would be perfectly fine to use for the calculations as you move forward. So roughly, in this data, the point estimate of the population is 80%. That is not my final answer, but it is the best point estimate for this to occur. All right, continuing on. Find the margin of error that corresponds to 90% confidence interval for the population proportion of Americans who watch football. Well, this is actually a harder problem than C because of the way we're teaching it this year. This year we're teaching it with these calculators. So what we can do is we can just jump down to C and then we'll come back and answer B. So let me come into C. To answer C, I'm going to use that calculator, and we're trying to come up with a 95% confidence interval. So I'm going to use my calculator, and it's a confidence test. So I'm going to go to my stat button, scroll over to test, and in this situation, I'm looking at one proportional interval because I'm looking for one proportional confidence interval. And I've got right here, my X value in this case is, what did we say? We said 650, correct, right? I'm sorry, 600. My N, the number in my population, is 650. So I'm typing in 750. Yeah, 6 and 750. And my confidence level is 0.95. I'm not showing you this part on the calculator because it's such a straightforward calculation. But I will tell you what I'm typing in. I'm literally saying my X is going to be 600. My N is 750. And then my confidence level, my C level, as the TI says, is 0.95. And then whenever I press calculate, I should get on the screen several values. And you've got to interpret these values on the screen. So I'm writing this up here in black because this is what my calculator is saying. It's saying 0.771, I'm going to round that a little bit, comma 0.829, close parentheses. And then I've got my p hat is equal to 0.8 and my n is equal to 750. Well, good. My n and my p hat match up with what I've already been kind of estimating here. That's a good thing. My n matches right there. That's good. My p hat matches from the first part of up there. But this right here, this is the powerful part of this problem, and that's what tells me my confidence interval. That gives me my confidence interval directly. So I know that 771 is less than or equal to my true proportion, which is less than or equal to 0.829. And what's really cool about this is we've gone through this very quickly, but the way you calculate these is you take your p hat and you minus your margin of error, and that estimates your proportion. And then you take your p hat and you plus your margin of error. So because I already know that my p hat is equal to 0.8, I know that right there, I can just substitute these things in right here and I can calculate these values. Let me back up and do this one at a time. So let's just say I look on the left-hand side. Because I know my p hat is equal to 0.8. So let me just use what I've got here and make a math problem, okay? I know that p hat minus my margin of error must equal 0.771. I know that that is the case. So what I'm going to write is I'm going to substitute in for my p hat. I know my p hat is 0.8, and then I just have to do 0.8 minus my margin of error is equal to 0.771. Doing some straightforward, really 4th and 5th grade algebra, I should be able to see that my E is going to be, so I'll just say 8 minus 0.8 minus 0.771 is equal to E. I'm not going to walk through that. Hopefully you can see where I'm getting that. If you can't, watch some videos on algebraic reasoning for solving one variables. I can send you some videos if you need me to show you that. But I end up getting that my my margin of error is 0.29 is equal to my margin of error, just with some 6th grade algebra. Now, if I wanted to check that, what I could do is I could plug in what I've just found here. I could plug this value in to this side of the equation. In other words, my p hat plus my margin of error should equal to 0.829. And since I know that my p hat, so here, let me write this out for a second. I know that my p hat plus my margin of error should equal to 0.829. Well, I know my margin of error from earlier is 0.8, and I just told you that my p hat is 0.8, and I just told you that my margin of error is 0.029. When I add those two values together, what do I get? I should get 0.829. So I know that I've got the right margin of error. I know that I've got the right point estimate. So I know that I'm ready to go and move forward. So on C, it's asking for the entire confidence interval. So my final answer is right here. But you need to be able to interpret what that is. And you should be able to find the margin of error just like I did with this little simple algebra here and here. Now, all of that is great, but let's go back and let's solve B, and then hopefully you'll feel a better understanding of all of these types of problems. So, on B, I'm trying to find the margin of error that corresponds to a 90% confidence interval. Again, you can do this with the calculations we did in class, or you can just use the calculator. And use the calculator, you're literally going to type in your X is going to be 600, your N is going to be 750. All of that is based on the situation. Your C level, or your confidence level, is going to be 0.90. And then you will just go ahead and press calculate. And when you do that, you should get a value of, remember the test that we're running here is one proportional interval test. I think it's A. Confidence level is 0.90. When I calculate that out, I should get this given back to me from the calculator. I should be getting, open parentheses, 0.775. I'll go ahead and round that. Let's go ahead and say 776 because that's going to round up pretty big. Okay, comma, 0.824. And remember, you've got to interpret what this really means. This is my confidence interval. So if I wanted to write this out in a complete answer, I could see that 0.776 is less than or equal to the true proportion, which is less than or equal to 0.824. What that is saying is that the true proportion of Americans that watch TV is between 77.6% and 82.4%. And I'm 90% confident because I've got a confidence level of 90%. So I'm 90% confident that the true population of Americans that watch football is between 77.6% and 82.4%. That's based on my data here. That data might have changed, but based on that data, that is my conclusion that I've got. Now, this question is great. I'm glad we got the confidence interval, but here I'm looking for the margin of error. To calculate the margin of error, you have to think about this confidence interval a little bit differently. And I did this already for C, but I'll do it very quickly again. This left-hand side, you calculate that by saying p hat minus the margin of error. Then you take that less than or equal to the true population, less than or equal to, and then the right side is p hat plus the margin of error. So we can take either of these sides and calculate margin of error very quickly just by doing some 6th grade algebra. So I'll take this right-hand side. I know these two things have to be equal, so I just set up the equation to have those equal. That p hat plus my margin of error must equal 0.824. How do I know that? It's defined that way. This defines my upper limit of my margin of my confidence interval. That is defined, so I've got to use that. Now I just substitute in what I have solved. I know that p hat is 0.8. I know that from part A earlier, so I just say that 0.8 plus my margin of error is equal to 0.824. Now I want to solve for E. Right now I've got a 0.8 over here, so I've got to get rid of that 0.8. Right now the 0.8 and the E are being added together, so to get rid of addition, to do the inverse of addition, I've got to subtract. So I subtract 0.8 from the left-hand side. If I subtract 0.8 from the left-hand side, I've got to subtract 0.8 from the right-hand side, and I get that E is equal to 0.024. Now you might be saying, well, Mr. Patty, you just did the margin of error on the bottom problem, and you got a different margin of error. You're completely right. Down below here, I got a margin of error of Down here, I got a margin of error of 0.029. Why is that different? It's different because I've got different confidence intervals. Your margin of error does depend on your confidence interval, so that's going to change quite a bit. So hopefully you understand how to get confidence intervals from the calculator and how to interpret those confidence intervals from the calculator.